back to the last set of notes for the week. This last set of notes is on Ohm's law, which is the sort of relationship that I've been talking about in the previous video. To get there, though, we need to do a little bit of thinking and conceptual work here. And so, let's check if I'm recording. Okay, good. If I have a battery, let's say, just a couple of thought experiments here, and a light bulb, and this battery is 1.5 volts, and my bulb here is lit. If I increase the voltage, increase V, what will happen to I? Will it increase or decrease? And we'll see that I is going to increase as V increases. So if we had another circuit here, same single bulb, and I have instead double the voltage, 3 volts. My bulb here is going to be much brighter than it was previously. It's related to the current and the voltage together, but essentially that's what happens. If we double the voltage, we double the current. So if this was 1 amp, now 2 amps would be running through the bulb. This relationship is a direct relationship. And when I say relationships in science, we kind of talk about setting up some kind of relationship here. So there's this symbol which kind of says as the current goes, as the voltage does. So if we increase one, the other one is going to increase. And there's just one more relationship because we've talked about I, we talked about V, and now we need to bring R into the equation. If I have another circuit with a resistor this time, let's say, and let's call it 10 ohms, 10 ohm resistor. We'll stick with 3 volts. If I increase R, because there's also a current going through here. If I increase R, what is going to happen to the current? Going to increase or decrease? Now my current, my V current in the circuit will decrease if I increase R. So if I were to say that the current in the resistor, it was found to be, I don't know, 3.33 amps, I would say that if I increase this resistance to 30 ohms, and we're still at 3 volts, the current running through would be now maybe 0.1 amps or something like that. It would get less. I increased R, I decreased I. This relationship, if we were to write it out, would look something like this. Because as R increases in the denominator of our 1 over R, this value overall gets smaller. which is what happens to I. So this is an inverse relationship. Combining these two together, something very useful pops out, which is I being equal to V over R. And this is Ohm's law. We can see that our relationships are still withheld here. As V increases, the numerator of our fraction gets larger, and so this overall fraction gets larger. So I also increases. That's one of our relationships, and then what we just talked about is R increases, I decreases still. So this is good. V equals IR, and they've just multiplied over the R from the denominator to the other side. And you'll see that we can do all kinds of stuff with this. If I have we'll just do a quick example. Two resistors in series. One of them is maybe 10 ohms. We have 5 volts on our battery, and then I don't know anything about this bottom resistor. Okay, so I can kind of set up almost a table of voltage of the battery. R1 should be this, and R2. 2, where here I'm looking at the electric potential difference, or the change in voltage. I mean, and a lot of times you'll just see V. The current going through each component, and then R, the resistance of each component. So I'm given a couple things. The voltage across the battery is 5 volts. The resistance of R1 is 10 ohms. And then that's it. So when you're doing these types of problems and finding missing values, you need to also remember the properties or the current and voltage rules when solving these. So in a series circuit, this is a series circuit, all of the currents are going to be equal, currents across everything. And each of the voltages are going to add up to 5. And let's actually, I think we need one more piece of information here. Let's do the voltage across this battery. So V1 is, 3 volts. 3 volts. So using Ohm's law, I can solve for this missing current of resistor 1. V equals IR, so the voltage across resistor 1 is equal to the current across resistor 1 times the resistance of resistor 1. So divide by 10. Here we get 0.3 amps. And as I just mentioned, all the currents are the same. 0.3 amps, 0.3 amps. So those were kind of free for me. And then I'm also just kind of looking for, okay, I have a V and an I here. I can solve for R across the battery. That would be 5 divided by 0.3, which would be something. 5 divided by 0.3 is 16.6 repeating ohms. And now I need to find resistor 2, and I can use another rule, which is the voltage drops across R1 and R2 have to be equal to the voltage across the battery. So I know that this is 2 volts. 2 plus 3 is 5. And then again, just solving for R, which would be 2 volts divided by 0.3, excuse me, 6.66 ohms. And then I also know that I'm right because I'm in series. The equivalent resistance is the sum of these two, which is equal to 16.66. So I'm all good. That's kind of how you solve a missing value problem, as they're called, using Ohm's law.